Welcome to the lecture series on object oriented analysis and design. So far in the lectures we have understood what was the different way of thinking in object oriented and how that different way of thinking has not been so easy to implement, to work forward. All these were spoken of, but in 1995 when the hard facts and statistics were coming in, it was becoming very clear that this method, which requires a completely different way of thinking, has never really taken off. In summary, it was very easy to comment on this technology, which was pulled out of cold storage 4 decades after it has been nicely deliberated amongst researchers, well documented. It was pulled out of cold storage, and in 5 years, 5 long years, where people have been attracted to this idea, people found that it is really an intellectually stimulating challenge, but then the statistics and facts were completely horrifying and it was almost written off. Object oriented technology is not something that will take us forward in terms of the way we wanted to do software engineering to ensure that the investment pays off. If it was only a puzzle, if it was only a program, if it was only something that is there to keep myself challenged, there is not so much of a concern. I had some money, I invested on this tool or box, and then I started playing some games, solving some problems to keep myself quite prim in terms of making the brain at work happen much more often than not. So, these are the ways in which we could bring ourselves to solve some good problems. There is no other way of learning also. Most of us do believe in that formal way of study, where we like to have problem statements 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So, if somebody can come up to 12th problem or 13th problem in terms of complexity, then it is adequately trained. We are slightly different in the formal way of learning and teaching. We are not looking at 10 skills. If you complete this 10 skills, everything is done. It should be in a different manner. They should understand, they should comprehend a problem statement, etc., etc., etc. It is not that to do 10 things, if you finish it, you are done. So, we have been talking about some such differences. So, what we have done so far is that it is nothing to do with the technology which is to be concerned about. It is well established, well stabilized, 4 decades plus 5 years of wonderful brains coming in, taking up the challenge. It is the way we have been looking at what to do with this technology for software engineering. So, towards that we started understanding a different perspective. Object identification, that is the most difficult exercise. For ease of study, as I said, everything has its flip side. For ease of study, for ease of formal teaching also, we take tangible objects, readily understandable, people understand everything, and then we say that without much of an explanation to unnecessarily deviate from the task. We strongly believe that tasking means our success is precise command lines, precise command statements, one by one sequentially we do it. That is what is our idea about tasking. If we start explaining too much, we are not likely to stay on course with the task, we are likely to digress. So, we need to have a good blend. However, we think that the complex nature of our problems as they evolve warrant a more generic approach, which was the strength of our field called software engineering. The more generic you are, the more you tend to understand the commonalities existing across seemingly different contexts, seemingly different problem statements, seemingly different domains, seemingly different stakeholders. So, it appears prima facie that all are solving different problems, but that power of abstraction which we like to build in our way of working, not too much of detailing step by step, but a power of abstraction where we like to have a larger picture in front of us, a bigger problem specification, something that is occurring at so many different places, domains where we did not think of. That was our strength in building software, the power of abstraction, nothing to beat power of abstraction in any problem solving, and we believe that if we start talking about tasking step by step, we are having a very good chance of losing out on that core strength by which we made software engineering happen as a field. But then if you do not do this, we will never be able to take it to the machine. And there is no point in arguing all along saying that we are exceedingly good when we have a language of our own choice, when we have a way of defining everything, specifying everything as step by step, sequence by sequence in a jargon or command line format which is precisely made for the machine, because eventually that is a machine that is doing it. So, in the process of bridging these two ideas, we started thinking that outside of the structured programming that made us come this far in understanding that yes, this is a concern, we need to have other paradigms. One of those emerging paradigms in 90s is object oriented. It is a completely different paradigm with its own terminology. Object identification, number one problem. We had handful of methods, none of them is so satisfactory, but then when there is nothing to bank on in a manner where without too much of detailing, without too much of explanation, people get together and start working, start doing things. So, that is how we started building the field called software engineering with a new paradigm called object oriented, which is our study. Each one of us is not equally endowed with putting all this exactly to fit with what is the work I am having on hand. Once again we like to look at the genericity, once again we want to see, is somebody else facing the similar kind of a problem, similar kind of a context. Maybe in all these decades, because the field is now 60 years, very good chance that people have already come across and best of the brains have been attracted into the field. This problem may not be so completely new as I am thinking. However, it may not be found exactly in a different context. These are the localization factors, so and so which we have been talking about. Can I replicate the solution? Can I repeat? Those are difficult questions to answer straight away. But then it is easy to start like this. Yes, I am facing a very tough kind of a context where within my reach I am not able to think of moving forward with this problem or solving it or making it evaporate, what to do, and very likely that because of the power of abstraction becoming so dominant in the field of software engineering, people would have faced it. Maybe it was not so apparent. So, we started talking about some generic principles. We did not have too many. Even the regular kind of a software engineering, the traditional software engineering had come up with a good, reasonably simple compilation of principles, concepts, then a practitioner's way of looking at it. So, we first split it like that, the way in which we should detail towards the machine, we said it will be practitioner's approach, that is the practitioner's way of working, and then there is a nice way of abstraction, the power of abstraction, but the paradigm was squeaking. It was not doing what exactly it is supposed to do, that is make us deliver what we are wanting to do on time within the budget estimate each time we are attempting. So, the new paradigm, but the difficulties were too many, each one of us cannot reinvent the wheel. Therefore, the methods came, and the terminology is very useful to think of: approach, methodology, method, procedure, technique, which we have completed in the last lecture. So, we said there will be some methods, each one has its own way of representing. We are not really looking at a common method as of now in this set of topics listed in this lecture, which we have done earlier, but then each method has focused certain things which are very important to understand. Whether the method was so popular or not, these ideas are very important. At the idea level, we think that everywhere there is a chance that the idea will be necessary. It is just that we did not find that dark corner which is making us look up to this bright light called an idea. We have not reached that dark corner. So, that is how it is. We may, it depends on what we are doing. So, the more challenges you encounter, the more chances are that you will see light in ideas which are just there, and that is why we keep imploring people to keep solving the problems, tackle the problems, face them, face more problems. That is when we see the need. Many things are like that. If you need it, you will find it. Necessity is the mother of invention. Wherever you go, this is true. So, how to create that need? Just to push yourself, keep solving the problem. Somebody have said this. Let us take one example. As soon as we finish this kind of a theoretical study, we will do some case studies and then talk about other things. So, tangible objects remains the number one handle to understand, to teach, to tell others, to work in a team. See, this is what I am talking about. Roles, incidents, interactions, different models, different notations, too rich in terms of graphical expression. We will see, we will move forward. Always the common way of thinking is a picture is worth more than 1000 words, but we always keep telling that not all pictures are worth more than 1000 words. We need to qualify that picture. That picture must reflect what we would have otherwise said in 1000 words exactly, then it is fine. Otherwise, it is not, we cannot simply tell that I am trying to draw a mountain, but it is appearing like a tree. Please wear a different color of goggles and this tree begins to appear as a mountain. Well, these are all the common jokes that we have in academics, and we do perceive that there is a realistic chance in the field of software, very high chance, not only realistic, very high chance that whatever we want to see will automatically appear, because it is so plastic, it is so easy to change. You can simply tell that from this particular standpoint it appears like a tree. We have seen some examples: a lion head, a giraffe body, a snake tail. All these things are good examples. It happens in the field of software more frequently than in other fields. Another nice word, seamlessness. We have spoken about all these methods. Each method is not presented here because it is complete. This is a method. There are some popular methods which gave us adequate assurance that we do not have to reinvent the wheel, and we are not in all our capacity attempting a serious and a complex problem that requires the world's best method to be identified first. That is not necessary. We do have a problem on hand, whether you want to call it a problem or whether you simply define it as we are attempting to write a program for. Usually the academic lingua franca is write a program to solve this. Usually we like to do that. It is not called a problem of list or whatever. Problem statement, write a program. Our problem is to write a program. That is how we talk. The standard terminology is like that. You have to write a program. That is our problem. So, what we have therefore understood very carefully is that the kind of programs which we are attempting to write need not wait for the world's best method to happen, and only then we will start writing the correct programs, or later on from program engineering to software engineering, migrate to software engineering. It is not necessary, and these methods have been reasonably good. We were able to solve a good chunk of application programs, application level problems, and we were able to manage well. However, it was fragmented. Each one would claim a different notation. Already we are having difficulties within the organization because each phase is a completely different team, each phase is a completely different notation. They do not like to talk to one another because the moment we see what is not happening, we get, as we keep telling, the moment anyone says I know this, it is not such a difficult thing to find out what he or she does not know. There is no black magic in it, it is just sheer experience. If somebody tells I know this, I can also find out if I want, but then we are positive in the way of teaching. Yes, you know this, you are attested for what you said you know, that is the claim. So, OODLE, these are all there, OODLE notation, inheritance, dependency. CRC cards is a very good case study that I have prepared some years back, which I wish to share later. But then class responsibilities and collaboration cards, these are all simple ideas which allow us to solve a good size of a problem, let us say 1 lakh lines of code. Each method can be stretched to make a lakh of lines of code happen, and code generation, other things are now automatic. So, what is the concern here? The concern is that the big picture has never emerged. What we were crying hoarse in 95, saying that object oriented as a technology has not been doing things. Technology will not do anything, we will have to use the technology to do things. Methods came in handy, but then people were not able to talk to one another. This method is different, this method is different. It is not merely the name of the method on which we are fighting it out, but the essence of object oriented in terms of abstracting and encapsulating has been completely lost. The number one reason is there were method wars. People were spending more time on making hair splitting arguments on which method, why this method. It's a business context, people are very aggressive competitors, they have to find, they have to justify. So, what is the next bet out? So, we said that neither the profession is benefiting from these ideas which were so good, and they were there much before some names which we have been talking about happened. Object oriented was there in 1950s, but then the most dominant names that were happening in 90s, early 90s, late 90s have happened much later. So, what we have therefore gotten used to is the fact that we need to somehow make sure that all this paradigm based aspects will flow into the exercise of software engineering. That is the charm of software engineering. So, in the process we found that there is a need to put together all these methods, and the solution that emerged, unified modeling language. So, what is this UML? Visualizing and documenting analysis and design effort. We have been always telling that the charm of object oriented is to facilitate top down analysis and a bottom up construction, while we are designing the need based approach to what we have analyzed. So, top down analysis, bottom up construction, the moment you have identified those objects and components, the construction can begin, and we want what we called from start to end, that is, as we begin the exercise with architecture to the time when the entire code can be bundled and kept aside, we want a common way of looking, because we have had these difficulties earlier on. Object oriented paradigm, by the sheer power of pitching a level above the abstraction and having some nice ideas like polymorphism, inheritance, state, behavior and others, has been the most promising to give this, and a good class of applications have benefited from this. So, what we said was we should know how to visualize and document the analysis and design effort to do all these things that we have been talking about. It is unified because it combines main preceding OO methods, Booch method, Grady Booch, OMT by James Rumbaugh and others, and OAC by Ivar Jacobson. Now, please remember that Ivar Jacobson's method, object oriented software engineering, has a public version, has a commercial version, business version. So, we have been happy that Ivar Jacobson's public version has given us what is called a use case method, which is a roaring success. We need to go back to the first example of a vending machine, which taught us the early lessons of how to get the focus on what to do without losing track of the power of abstraction. That is where the crux is. The devil is in the detail most of the times. If we start tasking ourselves step by step, step by step, step by step, we are very likely to lose a bigger picture or the power of abstraction that enables us to ask the question, did somebody else face a similar problem before? 10 years back, 15 years back, 50 years back, 60 years back. The power of research has always been that, because it captures the abstraction first. That is the power of abstraction. Modeling, because it is primarily used for visually modeling systems, many system views are supported by appropriate models. Language becomes very important, because we cannot hope to do all these to push it into a completely strange way of making the machine execute step by step. So, we said we should have a language which is at the same level, roughly we meet. The top down analysis is coming down, the bottom up construction is going up, somewhere we have a meeting point without any serious fight on why this is different, that is different, why this is better, that is better. So, unified modeling language, visually modeling systems. UML has its ancestry, Booch 91, that is the time when we were picking up the object oriented. Until then, we did not really have a consolidated text kind of a thing. OMT1, other, and OAC. So, please understand that this did not happen out of vacuum. Booch's method, OMT method, OAC method, all of them have been nicely developed, and if you look at it very carefully, they are not happening in vacuum, they are relatable to other methods. No paradigm has happened in a vacuum. We are not saying that by creating one paradigm called OO, we have killed all other paradigms or it potentially vanished. No, it does not happen. This paradigm has a scope like this, it draws very valuable experiential lessons to say that if you follow these, certain class of applications are likely to build to a complexity which will fetch back a productive and a return on investment that is good for business. The business will thrive. Booch 93, OMT1, OMT2, other, OAC. So, these have been variants, they have been talking about it, unified modeling 0.8, and all these things are very nicely documented and well made public by Object Management Group, OMG. So, we have been talking about all these exercises from 95. 95, the first flash. Byte is a very respectable magazine for computing, it was. These days Byte is not happening. So, when the Byte cover page has decried that object oriented is like this, we have had serious problems. Immediately, some of the good ideas of Booch 93 and OMT2 has gotten in, and well, in some sense we must thank these pioneers, Rumbaugh, Booch, and much later object oriented software engineering by Ivar Jacobson. So, gradually it became a language, otherwise it was only unified modeling picked from other, not from OAC. We had so many other methods, at least a dozen methods have been discussed in this set of lectures. So, UML happened, UML 1.0, UML 1.1, public feedback June to October 96. This was a very pioneering idea which was so popular with OMG, and gradually it gotten into many other forums. public document. Government of India had a mobile technology public document. We can comment, we can participate. This idea was very good. Whether we got such wonderful feedback even during this spell is something which is a moot point, but the idea caught on. We have so many forums today across the world which have a public window for debate, and we have also been advocating that while there is a public window, there must be a regret window in many cases, because all people are not experts. So, there should be a regret window. Ideally, I should be able to pick up what is wrong and then simply finish, close it. No, I am withdrawing, it is closed. So, these are all some good ideas that we have been talking about. UML 1.1, well, it all depends on what exactly we want to get the public opinion or implement a regret. Certain things are irreversible, certain processes are irreversible. Once it has happened, it has happened. There is no concept of rollback. So, we have been talking about multi-stakeholder partners. The terminology is still very old: fragmentary, unification, standardization, industrialization. So, OOSC has chipped in to facilitate these ideas, multiple stakeholders, which was called partners expertise. Industrialization, standardization, unification is the spell. We think that the bulk of the unification has happened because of Booch and OMT. OMT is very nice because it gave us the first very authentic mathematical foundation for defining the associations, for finding out the aggregations and generalizations. We banked on our sets and relationships, that is the function mapping, one to one, one to many. That was a strength on which we got the unification implemented. Fragmentary, yes, it has always been fragmentary. The entire object oriented field was almost talking about half a dozen on this method, half a dozen on this method, half a dozen on this method, and none of us are happy. Then why will anybody else take to object oriented? The power was so good, the fantastic power. So, we said industry fragmentation, all this happened because of OOSE, object oriented software engineering, and we thank the pioneers Booch, Ramba and others, and then Ivar Jacobson. So, after the 2.0 came, we pick up the exercise from 2002. Most of the times after 2002, wherever we have been talking about object oriented, it is exactly called UML, Unified Modeling Language. Nobody was using any other term. Nobody was talking about anything else other than UML. If somebody utters the word object oriented, it is exactly synonymous with UML, and that was UML 2.0, roughly after 2002. Books have changed, writing of the textbooks, courses have changed, everything has moved, fully moved to 2002. So, in summary, we have seen the historic development of UML, which is on such a firm basis, and the scope which has been so well thought out and well engineered into the context which we are working, namely software engineering. It does not lose the power of abstraction, we are not losing the grip on implementation or tasking. It is something that we thought anyone who attempted these two worlds has ended up neither here nor here. It is very common, even in real life it is the case. You are neither for Jesus nor for the Joe, you are neither here nor there. So, for many purposes, most of the times the human endeavor happens best when they are having a clear channelization, not try two worlds. It is very difficult to try two worlds to match them. So, we kept on saying the same thing. We tried top down, we tried bottom. They are good ideas which were there for ages. Putting them together and making it happen together, that was a challenge, and after 2002, it was exactly the same as UML and object oriented. Tomorrow we may have better methods, we wish that there will be better methods. People are not so happy with UML either. So, thank you, we will meet in the next lecture.